Hey guys, welcome back to my YouTube channel. So last class we have started discussing about the junction types. Like the uniform junction is the first type that we are taking into discussion, where the doping profile concentration will be uniform throughout the semiconductor. So this is the charge carrier diagram that we drawn in the last class. So extending this, let's go into find the electrical field and voltage between those things. So based on the Poisson's equation, we know that the electric field which will be directly proportional to dou V by dou X. So, or we can even make this as integral of dou V divided by epsilon dx. Okay, this is from Poisson's equation. So let me write that one also. So from Poisson's equation, we know that dou square V divided by dou X square, which will be equal to minus dou V by epsilon. So from here we are taking directly this one. So if we do this, then we can be able to get this one. From here we are derivating. So v, which will be dou V by dou X. Even if we integrate it one time, then we get the dou V by dou X. So for that we have added dx here. So here we have get a unique equation to find out the electrical field. So we know that in P region, the dou V which will be equal to minus q na. Okay. So if we substitute that in a E electrical field equation, then we will get q na divided by epsilon dx. So if we integrate it, there is everything is constant, so x only will get added into the equation. So na divided by epsilon x plus c1. So this is the first equation that we are getting. So here we need to find the c1 constant. Okay. So in order to find that, e of x will be equal to 0 at x equal to minus xp. So substituting this in the equation 1, we will be getting that 0 which is equal to minus q na divided by epsilon xp, which is minus xp plus c1. So if we use that, then c1 which will be equal to minus minus plus, then again it will be going to minus because we are moving to that side. So minus q divided by epsilon into xp. So now this substitute in the electrical equation, the c1 in the equation number 1, then we will get the e dash of x, which is function of x, right? So it will be equal to minus q na divided by epsilon x minus q na divided by epsilon xp. So if we take this common, then minus q na divided by epsilon x plus modulus of xp. Okay, so this is what the equation of electric field in the region minus xp to 0. Okay, so this is something straight. So if x is equal to 0, that is x of 0, then our answer will be minus q na divided by epsilon modulus of xp. So this one I have already said you. So in this lecture here I have represented the equation, right? So this one. So this one we already found out. So now this one we have found out in the region xp. Similarly in xn also we can calculate. So we have find out how the equation has came here. Okay. So let's get into the voltage region. So even if we do the same thing in the n region, if you guys try, then rho v will be different. So rho v will be q nd. So q nd. So if we found out that, then our e of x which will be equal to q nd divided by epsilon. I'm directly writing the last equation. If you guys need, you can try it, minus xn. So this is the electric field equation where it will be from x to xn. Okay. So here if we substitute e naught, e of 0, then that will be equal to minus q nd divided by epsilon into xn. Okay. So this thing also we have already find there. So if we need to find out the voltage, so v of x is nothing but the negative integral of electric field. We know these formulas from EMF. So once we done that, then we will be able to get the voltage equation. So let me draw the charge neutrality diagram here so that you guys will be able to understand something more clearly. So this is an PN junction diode. Okay, so here we are going to draw the electrical field, charge density here. Here we are going to draw electric field here. Then here we will be drawing the voltage. So I will be combining all this in one so that you guys can understand it easily. So let me draw a depletion region also. So let's take this as a depletion region here. So quite a small depletion region. Okay, so let me make a dotted line for this. Even you guys can try how to draw it. So we have already draw something up to level, but we haven't tried we haven't drawn. So up to E you guys can draw it. So this is for PN junction. So this will be negative superscript of holes. This will be with the depletion region. Here only donor atom. Here donor atom with electron. Okay. So if we draw the charge neutrality, this will trace the boundary here. So it will trace the boundary here, and it will come quite downward, and then it will be tracing this way, and then goes to top, and then back to this, and traces the boundary again. Okay, so this is how the thing will here. So if you know that the electrical field will vary in this direction. So this one also we already discussed. Why this is that the first charge is negative, so it's a degraded in negative region, and then positive, so it goes in this region. So we know that it is an integral of this electric field. So then the charge will initially will be, the voltage curve will be initially 0. After that it will slowly rise whenever there is a change in electric field, and then it will saturate. After this region it will be straight, there will be no changes. Okay, so this is what, let me name everything. So this is negative, this is positive, so this is charge density, this is charge density. Okay, so this is electric field, so it will be E0, this is Xn, this is minus Xp. Okay, so this is electric field E of X, this is V of X, this is potential. So this difference, right, so this top two difference is V0. So this is what the potential that is developed. We already found this value also. Okay, so I think we are good to cover all the things is in here, like we have find out the charge neutrality, density, everything, but only thing left is that V of X we need to find. So V of X we know that V of X, which will be equal to integration, negative integration of electrical field. So V of X can be found from the electric field. So let's take any electrical field. Let's take a P region electric field, which will be minus Q Na divided by epsilon x plus xp modulus, okay, of dx. So if you integrate it, here x plus x of p both is dependent on x, so it will be getting some terms here. So Q Na epsilon, this is constant, so let me take it outside and keep it outside. This will be x square by 2, this will be x xp plus c. Okay, constant will be added here. So let's take this as equation 3. Okay, so C3 we need to find out C the C here, so let's make it a C3. So we have to find the C3. So at x is equal to minus xp, we know that v of x will be equal to 0 at this point. So this point v of x which will be equal to 0. So we are taking that point and substituting that in here. So then v of x which will be equal to 0, v of 0 which is equal to 0, sorry, v of xp, v of minus xp which is equal to 0. So 0 which is equal to Q Na divided by epsilon xp square divided by 2 minus xp square plus C3. So if we bring all the term to, if we cancel it, it will become as minus 1 by 2 xp, then C3 which will be equal to Q Na divided by epsilon, this to that side, so it will become positive. So x square divided by 2. Okay. So let's substitute the C3 in the equation of v of x. So v of x, which will be equal to q na divided by epsilon. So let's take all the term outside. So x square plus 2x xp plus xp square. So this is what the voltage equation. So if we simplify this, we will be adding the term like 2 epsilon x plus xp the whole square. Okay. So I hope you guys able to understand. This is the voltage field from minus xp to x, because we take the threshold region in the negative region. Similarly, in the n region, we can able to calculate it. So similarly in n region, if we apply the condition, then we will be able to get the equation. I am leaving this to you guys, so you guys can also try this one. So in this, the boundary condition need to be v of x, which will be equal to x naught when x is equal to xn. So we have to substitute this one. Then we will be getting v naught, which is equal to q divided by 2 epsilon na xp square plus nd xn square. So you guys can try this one. If you guys not getting, please ping in the comment section. I will point out the right thing to work out. So this is how we will be calculating the things. So we know that w, which is equal to xn plus xp. So if we substitute this here, then we can get the equation like. So we also have another one equation, that is na xp, which is equal to nd by xn. Combining these two equations, let's find out that xp, which is equal to na nd na divided by into xn. So if we substitute that in the w, then w, which will be equal to, then take it x, let's take x out, xn outside. So nd by na. Okay, so if we cross multiply this thing, we will be getting another one equation where w, which will be equal to xn 1 plus nd divided by na. Okay, so from here, if we need to find out the xn, let's cross multiply this w, then this nd na will go to top divided by na plus nd. Similarly for xp, we can find w nd divided by na plus nd. So these are quite formulas that will be using in formulas, using in problems. So I hope we have find out the voltage equations in both p region, n region and everything. But these formulas will not be used much greater, but the we not the thing we have find out another one formula, right? So that will be very much helpful in all the cases. This is another one important things, so you guys can remember these things also. So it will be helpful for us to solve any kind of problems. So if we substitute the value of xn and xp in the v naught equation, like in the v naught in this equation, if we find out, then we will be able to get the depletion width formula. So that the equation that solving is not needed. So for now, let's note it. The depletion width formula, that will be equal to square root of 2 epsilon q divided by 2 epsilon v naught divided by q 1 divided by na plus 1 divided by nd. Okay, so this you can remember. So this is what the depletion with the length will be depending on the concentration Na and D and V naught depletion potential. So this is how the V naught width will be decided there. So I hope it's understood for you guys. So this V naught is there, right? So this V naught is the junction potential. The V naught is the junction voltage or junction potential. So we have find out that one. So this potential will vary based upon the input. So Vj will be if it is V naught or Vj, anything we can say it, that is not a problem. That will be open potential, but this V naught will be equal to V naught plus Vr if it is reverse biased. Okay, so if the reverse bias is applied, then the extra voltage will be added so that the depletion width will increase. If V naught, which is equal to V naught minus Vf, if it is forward bias, then what will happen? The depletion width will decrease. So based upon this one, we need to substitute the V naught values here. Okay, So I hope it's understood for you guys. So this is a constant formula, but based upon the reverse bias or forward bias, the depletion width changes can be applied here. So far we have seen in the linear junction, so how the electrical field and voltage will be can be calculated. So this is from the Poisson's equation we have taken identity that the rho v, which is equal to minus q and v, this is charge potential, from where the electrical field can be found by integration of dou v divided by epsilon dx. So once we substitute and integrate all the constant values, we will be able to get the electrical field in p and n region. So I hope that is understood. Then from that we are drawing the charge potential diagram. So this is one of the very important term that is needed in everything. So then we are finding V0, and then from the V0 we are substituting Xn and Xp formula so that we can get a W. So this is a depletion potential formula. So this was some quite numericals and some equations that we have dealt so far. So if you guys haven't able to understand, please remember all the equations end formula, because in GATE or IES problem solving these kind of things are needed. So you guys can just revise or remember those things. If you guys able to understand it and able to get it, so you guys can also substitute and learn it every time. Okay, like, share and subscribe the channel. Stay tuned guys.